Hello everyone. Our today's topic for the A-level chemistry is substitution of ligands. In the previous lecture we have discussed what are the ligands, what are their types. Now we are discussing substitution of ligands. Whenever a coordination complex is formed, then its stability matters. Now, ligand substitution is mainly affected by the stability of the complex formed. If the complex formed is more stable, then the ligand exchange will become difficult. And if the complex formed is unstable, then ligand exchange will takes place quite easily. Now, along with the stability of complex form, there are some other factors which also decide the ligand exchange. Number one factor is the concentration, and next another factor is the nature of the ligands. Some ligands are termed as strong field ligands and some ligands are weak field ligands. If the ligand has a negative charge, definitely whenever the coordination complex will be formed, negative charge ligand will repel negative charge ligands. On the contrary, if a neutral ligands are there, neutral ligands will never repel each other, so the stability of complex will be enhanced. Maybe if we look at the solution of copper 2 ion, actually the copper 2 aqueous ion means it is present as a coordination complex ion, C hexa aqua copper 2 ion, hexa aqua copper 2 ion. Now, if we add sodium hydroxide solution in this solution, what we will get? We will get this complex, and this will be from blue colored solution we will get light blue precipitate. Light blue precipitate that is of this complex ion, tetra aqua by hydroxo copper complex. This gives light blue precipitate. It means that when we have added sodium hydroxide solution into this aqueous solution of copper ion, we get light blue precipitate. Secondly, if we have copper 2 ions, or if we have the same complex, if we add concentrated ammonia in this solution, of copper 2 ion or in this precipitate, what will happen? The more stable complex will be formed, which is tetra amino by aqua copper 2 ion complex. This is a deep blue solution in which the whole light blue precipitate is totally dissolved, which turns first in deep blue precipitate and then dissolves. It means that instead of this, more complex is formed in this. Next, if we add concentrated hydrochloric acid into copper positive aqueous solution, which is present as a hexa aqua copper 2 ion solution, if we add concentrated hydrochloric acid into it, it will transform into tetrachloro cuprate ion, and this will give us a yellow solution. the color will change from blue to yellow solution. Here the coordination number of copper ion is 6, but here the coordination number of copper is changed to 4. It means that due to the concentration, hydrochloric acid exchanged all the water molecules. Now instead of 6 ligands, due to the larger size and negative charge, chloride ion, only the 4 chloride ions are capable to occupy whole of the space around the copper positive 2 ion. That's why this tetrahedral geometry of this complex is formed and color change from blue to yellow. This shows that ligand substitution takes place only according to the stability of complex form, or then depending upon concentration, and then depending upon the nature of the ligands. For example, we have already learned that carbon monoxide is a very dangerous gas. Whenever we inhale carbon monoxide, it forms complex, it forms coordinate covalent bond with iron positive 2 ions. Iron positive 2 ions in the blood, and this bond is so much strong and the stability of complex is too much high that it never breaks. That's why the site which are used to transport oxygen to the different body parts by the blood, that is blocked. That's why carbon monoxide proves to be a very fatal gas for the humans. Next, for example, if we, in case of cobalt, instead of copper, if we consider cobalt aqueous, means the solution is of cobalt is the same, hexa aqua cobalt 2 ion. Hexa aqua cobalt 2 ions. Now, in case of this hexa aqua copper 2 ions, whenever the cobalt ions are treated with concentrated ammonium, whenever the cobalt hexa aqua cobalt 2 aqua solution is treated with concentrated ammonia, then 6 ammonia displaces all the 6 water molecules, forming the complex quite easy, which is represented as cobalt NH36, cobalt NH36 with positive 2 ions, and producing consequently 6 water molecule. Now, the cobalt hexa with 6 water molecule or hexa aqua cobalt is pink in color. It is pink in color. While when the same we produce with concentrated ammonia, that also change its color. Now, this test, if we treat cobalt hexa aqua solution with concentrated HCl, definitely 4 chloride ion displaces all of 6 water molecule, and we get cobalt tetrachloro cobalt positive 2 ions, and producing how much? 6 water molecules. 6 water molecules are removed. Now, this copper tetrachloro cobalt 2 ions, this is actually in anhydrous let us form blue in color. Blue in color. Now, this complex is less stable as compared to this. That's why in the chemistry we use this color. We use this color complex as a test for water molecule. If we take cobalt chloride complex ions, and if we put water containing solution into it, if we put water containing solution into it, what will happen? Immediately cobalt will form hexa aqua cobalt 2 ion. Immediately, quite easily, releasing 4 chloride ion. This indicates that the complex of cobalt formed with chloride ion is less stable as compared to cobalt 6. So, the ligand exchange takes place automatically and water molecule replaces all the chloride with the ion, and the color change from blue to pink because this hexa aqua cobalt 2 ion solution is pink in color, and that's why this is used as a test for the water molecule presence of water molecule. In this manner, ligand exchange can take place quite easily depending upon the stability of the coordination complexes formed. I thank you all.